Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from current electricity concept. To know the solutions for first 4 questions, check out my playlist. Now let us go to our fifth question. A resistance wire connected in the left gap of a meter bridge balances a 10 ohm resistance in the right gap at a point which divides the bridge wire in the ratio 3:2. If the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire is. Okay. Now let us see what he gave. He said that a resistance wire is connected in the left gap of the meter bridge. So here he connected a resistance wire. Here he connected a resistance wire in the left gap. That is this. And in right gap, what did he do? He took 10 ohm resistance. So here he placed 10 ohm resistance. Now what is he saying? This wire of resistance R balances the bridge wire OA at a point in the ratio 3:2. That is, the balancing point divided this wire OA in the ratio 3:2. That means the balancing point will be somewhere here. Let me take it as B. Okay. So this B divided the wire OA of length L in the ratio 3:2. Okay. Next, if the length of the resistance wire is 1.5 ohm, what did he give? He gave the value of LR, that is length of resistance wire, as 1.5 ohm. Then the length of 1 ohm of the resistance wire is, means what you have to calculate? You have to calculate the resistance of 1 ohm of the, you have to calculate the resistance of, you have to calculate the length of a wire whose resistance is 1 ohm. Okay, that's what you have to calculate. Okay, see now what did we take? We took the length of OA as L. OA as L, and we know that this B divided OA in the ratio 3:2. Okay, now let rho be the resistance per unit length of the wire. Then what will happen? The resistance of OB will be equal to rho into 3/5 of L. Okay. Similarly, let me write it as ROB, which is nothing but resistance of OB. Similarly, the resistance of BA will be equal to rho into 2/5 times that of L. Okay. So that's one thing. And B is the balancing point. Now let us apply this Wheatstone-Bridge condition. What is the Wheatstone-Bridge condition? P by Q is equal to R by S. Okay, this is Wheatstone-Bridge condition. Now if I apply this condition, P is resistance of this. Okay, that is what you are supposed to calculate. That, let me take it as RL. Q is resistance of OB, which is nothing but ROB. R is resistance connected in the right gap, that is 10 ohm. S is resistance of this part AB, which I took it as RBA. Okay, now if I substitute all this, what will I get? P, which is nothing but RL, resistance of our wire, by Q, that is ROB, that is rho into 3/5 times that of L, is equal to capital R, that is 10, by S. S is 2/5 times that of L into rho. Okay, so this row will get cancelled. This L will get cancelled, and this 5 will get cancelled. Then what will I get? That implies resistance RL is equal to 10 into 3 by 2. So that is equal to 15 ohm. That means that the resistance of the wire that I connected in the left gap is 15 ohm. Okay, so now what you have to do? You have to calculate the resistance of 1 ohm. Okay, we came to a conclusion that 15 ohm resistance is given by a wire of length 1.5 meters. Okay, now what are we supposed to calculate? We are supposed to calculate the length of the wire that gives resistance of 1 ohm. That is, 1 ohm resistance will be given by a wire of length how much? So which is nothing but L 1 ohm, that is length of wire which gives a resistance of 1 ohm. Okay, then what will I get? If I cross multiply, I will get 1.5 into 1 by 15. Okay, that is equal to 1 by 10 meters. That is 1 into 10 power minus 1 meters, which is option D in our question. Okay, now let us go to our next question. Which of the following graph represents the variation of resistivity with temperature for copper? Okay, so what did he say? He asked us to find the graph which shows the variation of resistivity with temperature for copper. Okay, so the answer for this is this. Okay, so for copper, the resistivity will change with temperature like this, and this is the graph for semiconductor. Okay, semiconductor. And for semiconductor, we know that the value of coefficient of resistivity is negative. That means as temperature increases, the value of resistivity will decrease. Okay, and this is for nichrome. Okay, so for nichrome, what happens is that the dependence of resistivity on temperature is not so significant. Okay, significant. What does it mean? It means that resistivity, the variation in resistivity with temperature, their resistivity will not change very rapid with change in temperature. Okay, so this is for nichrome. The other mistake that generally people do is, we know that the formula that shows the variation of resistivity with temperature is rho T is equal to rho naught into 1 plus alpha delta T. Okay, so this is the formula that shows the variation of resistivity with temperature. Okay, now if you see, this is of the form y is equal to mx plus c. Understand? Then what will you do? Generally for this, many people will opt this as the answer. Okay, but this is not answer. The reason is that this formula is valid only for limited range. What do you mean by limited range? Means the variation in temperature is up to certain extent. Then only we can use this formula. If the variation in temperature is large, then this formula will not be valid. Okay, now see, let me take alpha as positive. That is in the case of metals. Okay, in the case of metals. Then what happens? If you take limited variation in temperature, that is small variation in temperature, rho T varies linearly with change in temperature. Okay, so nichrome is a metal and copper is also metal. See, for nichrome anyhow, resistivity is changing linearly with temperature. For copper also, see, initially for small change in temperature, the variation of resistivity with temperature is linear. Okay, whereas for a large change in temperature, what happened? This linearity is lost. It took this curved path. Okay, now let us go to our next question. Our next question is, a charged particle having drift velocity of 7.5 into 10 power minus 4 meter per second in an electric field of 3 into 10 power minus 10 volt per meter has mobility in meter square volt inverse second inverse of. So what did he give? He gave that he has a charged particle whose drift velocity is Vd is equal to 7.5 into 10 power minus 4 meter per second, and this charged particle is moving in an electric field E is equal to 3 into 10 power minus 10 volt per meter. Now what is he asking us to calculate? He is asking us to calculate the value of mobility. Mobility is equal to how much? Okay, we know that the formula for mobility is mu is equal to drift velocity per unit electric field. That is mu is equal to Vd by E. If I substitute, it is a simple sum only. Vd is 7.5 into 10 power minus 4 by electric field is 3 into 10 power minus 10. Okay, if we solve this, we will get 2.5 into 10 power minus 6. Okay, we will get as 2.5 into 10 power minus 6, which is D option. Okay, now let us go to our next question. Our next question is, the solid which have negative temperature coefficient of resistance are. Means you have to find the solids which have negative temperature coefficient of resistivity. Okay, so now we know the formula for resistivity as sigma rho is equal to m by NE square tau. Okay, where m is the mass of charged particle, E is the charge of charged particle, N is the number of electrons per unit volume, that is charge density, tau is relaxation time. If you observe in this formula, m comma E are constant. That is rho mainly depends upon n comma tau. Okay. Now let us see how tau changes with temperature. Okay. Now as temperature increases, what will happen? The value of drift velocity will increase. Okay. As the value of drift velocity increases, the value of relaxation time will decrease. That is average time between two collisions will decrease. Okay. So what happens? Increment in temperature made tau to decrease. Okay. Now decrement in tau will make resistivity to increase. Okay. So the final conclusion is, as temperature increases, the value of resistivity will increase. This is for all materials. That's what I wrote here. So for all materials, that is whether it is insulators, semiconductors or metals, whatever it may be, what happens is, as temperature increases, the value of resistivity will increase. Okay. Now let us go to the case of metals. In the case of metals, what happens? The value of N is almost independent of temperature. That is, the charge density doesn't change with temperature. Means I can take like this. That is, N is constant. Now in this formula, in the case of metals, the only variable is tau. So in the case of metals, resistivity depends upon tau, and we know that as temperature increases, resistivity also increases. So what happens in the case of metals? As temperature increases, the value of resistivity will also increase. That is, the value of alpha is positive in the case of metals. So that is first point. Next point is, now let us go to other classification, that is semiconductors and insulators. In the case of semiconductors and insulators, what happens is, as temperature increases, the value of N will also increase. Okay. Now as N increases, what happens? The value of resistivity will decrease. Okay. Now in the case of semiconductors and insulators, you have two factors, that is resistivity depends upon relaxation time and resistivity depends upon number of electrons, number of charged particles per unit volume. Okay. So in the case of charge density, what happens? As temperature increases, the value of rho will decrease. That is first point. Whereas in the case of temperature, as temperature increases, what happens? The value of resistivity will also increase. So in the case of semiconductors, resistivity, in one case resistivity is decreasing and in other case resistivity is increasing. Okay. So the point here you have to observe is, this decrement will be more compared to this increment. Okay. So on a whole, what happens? As temperature increases, the value of resistivity will decrease. That means for semiconductors and insulators, the value of alpha will be negative. Okay. So the answer for this question is A. That is, insulators and semiconductors which have negative temperature coefficient of resistance. Whereas for metals, you will have positive temperature coefficient of resistance.
If you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. Do like and subscribe, because your single like and comment will encourage me for making better videos. Thank you.